All right, so we're trying something new where you can actually see my face today. So we'll see how this goes. So this is the review for your Unit 6 test. Oops, not that. So starting out, we have our trig functions that we're going to have to use. So remember with this, you're going to have SOHCAHTOA. And remember that means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I want sine of A, I'm going to be looking at this angle. So from this angle, I know that 15 is my hypotenuse and that 12 is my adjacent. And I know that that's my adjacent because it is part of what makes up that angle. And then 9 will be my opposite because it is not touched by the angle lines themselves. So for sine of A, that is opposite over hypotenuse. So our opposite is 9 over our hypotenuse 15. And 9 over 15 can be simplified because they can both be divided by 3. So that would give you 3 over 5. And 3 over 5 as a decimal is also 0.6. So on your test, you will have to be able to give me both of these numbers. Because some people have been missing them because they've been trying to write it with like sine of 40 and stuff like that. So you don't need to do that. So for cosine of A, it is adjacent over hypotenuse. So adjacent over hypotenuse. So it is 12 over 15. And 12 over 15 can also be simplified because they can both be divided by 3. So 12 becomes 4 and 15 becomes 5. And 4 over 5 as a decimal is 0.8. And then for A, tangent of A, it is opposite over adjacent. So opposite over adjacent. So 9 over 12. And 9 over 12 can also be simplified by dividing by 3. So that becomes 3 over 4, which is 0.75. So now we're going to switch over to angle B. So now that we're at angle B, the only things that change is that my adjacent side that was for angle A is now my opposite side, and that 9 is my adjacent side. So it might help you if you label your triangles. Just remember that it is based off of the angle that you're referring to. So because we're talking about angle B now my adjacent is 9. If I was talking about angle A, then my opposite would be the 9 instead. So for sine of B, it is opposite over hypotenuse. So that is 12 over 15, which is 4 over 5, which simplifies to 0.8, or as a decimal is 0.8. And notice it's the same as cosine of A. Again, it's because you switched your perspective. For cosine of B, it is adjacent over hypotenuse. So adjacent is 9 over hypotenuse 15. And 9 over 15 becomes 3 over 5, which is 0.6. And then tangent of B is opposite over adjacent. So opposite 12, adjacent 9. And 12 divided by 9 can be simplified to 4 over 3, which becomes 1.33. Repeating, so just 1.33. For number 7, it is just sine of 61, so that's where you grab your handy-dandy calculator and you just type sine 61. Make sure that you actually have, sorry, I lost my train of thought. Make sure that you have it in degrees. So when you do sine of 61, it should be 0.874. I don't know if you can see this or not because I don't have my preview. But because it's 874, oops, 0.8. Ooh, no, things are going crazy. So because it's 0.874, this 4 tells me to just keep my 7, so it's 0.87. For tangent of 55, it gives you 1.428. So this 8 tells us that we need to round this 2 up to a 3, so it's 1.43. And then cosine of 43 is 0.731. So the 1 tells us to keep it, so we have 0.73. Okay. For 10 through 15, we're just finding lengths, and we're going to be using trig. So we're going to have the SOHCAHTOA again. And in order to pick which trig function you need to use, you're going to base it off of one of your angles. So for this one, I'm going to base it off of this 75-degree angle, and I want to find EF. So again, labeling the triangle can help you a lot. So if we're doing EF, that is opposite of the 75. And then 8.1 to the 75 is the hypotenuse. So now that we have it labeled, I need a trig function that has opposite and hypotenuse. Well, the only one that has opposite and hypotenuse is sine. So we're going to have sine of 75 equals opposite x over hypotenuse 8.1. So then to solve this, you're going to have to multiply both sides by 8.1 because we have to get rid of that fraction. So then when you do that, we have 8.1 times sine of 75. Notice I put the 8.1 in the front because I don't want to accidentally get it mixed up with the angle itself. So then 8.1 times sine of 75. And if you have a graphing calculator, you can literally just type it in straight like that. And that gives us 7.823. So then because we need nearest hundredth, we're going to have 7.82 for EF. Okay, so for AB, we're going to do the exact same thing. So AB is this side right here. Based on this 34-degree angle, 4.2 is opposite of that angle. Oops. And AB is adjacent because it's right next to it. So to set this up, I need a trig function that has opposite and adjacent. So opposite and adjacent is tangent this time. So we're going to have tangent of 34 equals opposite, which is 4.2, over adjacent, which I'll just put as x. Now this is slightly different than the one before because the x is in the denominator. So you have to actually multiply both sides by x. And when you do that, they cancel out on the right. So we have x times tangent 34 equals 4.2. And then, because we have this tangent with the x, we have to divide by tangent 34. And 4.2 divided by tangent of 34. And again, most of your calculators can just handle it. But it is 6.226. So because we have that 6 there, it tells us to round this 2 up. So we have 6.23. And this is inches. And the one above was centimeters. Bad me. Always include your units if you have them. Okay, so for UV, we have to, looking at this 80-degree angle, we're right here, and UV is our hypotenuse. So I'm just going to go ahead and label that right now, hypotenuse. And 11 is opposite of that because it does not touch the sides of the angle. Okay, so notice the 11 is my not highlighted. So for opposite and hypotenuse, that would be sine because sine is the SOH. S-O-H. So sine of 80 equals opposite, which is 11 over hypotenuse, which we don't know. So then to solve this, we're going to multiply both sides by x. Oopsie. So then that goes away, and we have x sine 80 equals 11. So then, because we have x times the sine of 80, we're going to divide by the sine of 80. Boop, boop. And 11 divided by sine of 80 is 11.169. So then this 9 tells us we need to round up. So instead of 11.16, it is 11.17. Okay. To find PR, so that is this side right here, looking at the angle we are given right here, PR is adjacent to that angle. And then 7.2 is the hypotenuse. So if you're afraid you're going to mix up adjacent and hypotenuse, all you have to do is find your hypotenuse first. So remember that hypotenuse is always opposite of the 90-degree angle. So in order to find PR, I need adjacent and hypotenuse, which is cosine. That's the CAH. So we have cosine of 29 equals adjacent, which we don't know, over hypotenuse, which we know is 7.2. So then to solve this, we just have to multiply by the denominator. So 7.2. And some of you may not actually write this step that I just wrote, but when you do 7.2 times the cosine of 29, you get that x is 6.297. So that 7 tells us we need to round up. So instead of 29 down here, now we're going to have 6.30. Okay. So to find xy is this side. So labeling the triangle, 12.3 is my hypotenuse because it's opposite of the 90. And then the blue highlighted part, the xy, that is adjacent. So again, we have adjacent and hypotenuse, which is cosine. So cosine of 33 equals unknown adjacent over hypotenuse, 12.3. So then we're going to multiply both sides by 12.3. And 12.3 times cosine of 33 gives us 10.315. So then this 5 tells us we need to round up. So it is 10.32. And this is centimeters. Okay? Now, the only other way you would have used a different trig function for this is if you had done, and this would have been a way more extra work, but if you had subtracted from 180 and found that angle Z was, let's see, what would that be? So if you'd found that angle Z was 57 degrees, then you could have also done sine of 57 equals opposite over hypotenuse. Other than that, you would not have been able to do any other trig function. All right, so to find JL, right here, oopsie, that's that side. To find JL, because we're looking at this 47 degrees, the 1.4 is opposite of that, and JL is adjacent. So then opposite and adjacent is TOA, it's the tangent. So we have tangent of 47 equals opposite 1.4 over adjacent, which we don't know. So then we multiply both sides by x so that it cancels out on the right. So we have x times tangent 47 equals 1.4. And then we're going to divide by tangent of 47. So then 1.4 divided by tangent 47 is 1.305. So then the 5 tells us we need to round up. So then we have 1.31, and this is centimeters. Okay. So just something to keep in mind when you're setting this up is that we are looking for you to have this piece right here. Actually set it up. And notice that with the all the trig functions, it's always the trig function and then its degree measure and then the ratio for that degree measure. So just make sure anytime you have to set these up that you are making sure you have all the pieces that you need for this. So for 16, 17, 18, it's just straight, put it into the calculator. So this is the inverse functions. So remember, inverse is when you're looking for the angle measure is for, ooh, wow, I can't write when it's upright like this, is for angle measures. So when you do this, you're actually going to have a little degree with your answer. So inverse sine of 0.82, and you really do just type it in the calculator straight like that. I don't even know if this is backwards picture or not, so we'll see. But it is 55.08. So because we're rounding to the nearest degree, 55.08 is just 55 degrees. Okay. For inverse cosine of 11 over 12, again, you can type it in exactly as you see it. You don't have to do anything fancy. Don't give me decimals. Just type the fraction. And that gives me 23.55. So because we have that 23.5, it tells us to round up to 24 degrees. And then for tangent of 5.03, it is 0.08. So because we're rounding, again, nearest degree, it is going to just be 1 degree. which is teensy tiny. Okay, so for 19 and 20, to find the unknown angle measures, again, inverse is for angle measures. So to set this up, it's a little different than the regular trig functions, but looking at this, you can pick whether you want to use h or g. It's kind of up to you. So if I start with h, looking at this, 5.9 is my hypotenuse and 3.5 is my adjacent. So because I have adjacent and hypotenuse, that is cosine. So because I need my angle measure, I'm going to do inverse cosine. And instead of having cosine and then an angle degree, you're going to have cosine and then your ratio. So it's going to be 3.5 over 5.9 for cosine. And it might not be a bad idea to say that is equal to h or g, or whatever angle you're looking at. So if we do the inverse cosine of 3.5 divided by 5.9, that gives you 53.6. So the nearest degree, we have that h is 54 degrees. To get angle G, you can either do trig again, or you can just subtract from 180. So if you wanted to use trig, 3.5 would be your opposite now over hypotenuse. So you would have inverse sine of 3.5 over 5.9 equals G. And if you do inverse sine of 3.5 divided by 5.9, you get that G is 36.3, which is just 36 degrees. If you had done it by subtracting, my handwriting is not good today, you'd have 180 minus 90 minus 54, and then that would also give you your degree if you need it. Okay, so either method in the green doesn't matter, up to you, but you should get 36 degrees and 54 degrees. For number 20, we're going to do the same thing. Pick an angle you want to start with. I'm just going to start with Q. So if I'm looking at Q, 8.6 is opposite, and 9.9 is adjacent. And I know it's not my hypotenuse because it's not opposite of the 90. So then, because it's opposite and adjacent, that is tangent. So let me rewrite that prettier. So we have tangent, but because we're looking for angle measures, it's inverse tangent now, and it's opposite over adjacent. And this is for angle Q. So inverse tangent of 8.6 divided by 9.9 is 40.9. So rounding to the nearest degree, that would be 41 degrees. And to find angle N, if you just want to practice the trig, my adjacent is now opposite, and my opposite is now adjacent because we just switched sides. So then you're still going to use inverse tangent, but instead of 9.9 being the denominator, it is now the numerator over 8.6, like that. And that's going to equal N. And, oh my goodness. Doop. So then inverse tangent of 9.9 divided by 8.6 is 49.0. So because it's 49.0, it's just going to be 49 degrees. And again, you could have also just subtracted from 180 and done 180 minus 90 minus 41 to get 49. Both would have worked. All right, so we have to now solve right triangles. So remember, when you're solving right triangles, you are rounding angles to the nearest degree and sides to the nearest hundredth, because I had a lot of people that were losing half points because they were rounding wrong. So it does not matter where you start. You can start with the sides, you can start with the angles, doesn't matter. But in number 21, because we are given an angle, we can just subtract from 180 in order to find it. If we were not given the 61, but we were given, like, let's say this side was 5, then you would use inverse trig and find them that way. So like if we were finding angle L, it'd be opposite over adjacent, so then you'd have to use tangent. But good news is you were given an angle. So the easiest way to get angle N is just to subtract from 180. So 180 minus 90 minus 61. Let's see, 9. That would give us 29 degrees for N. And if you didn't believe it, you could also do inverse trig, but you would have to get another side measure, which could get more complicated. So next we're going to find ln, which is the hypotenuse. So I'm just going to label as h. So because I want to look at this 61 degrees, that 8.5 is opposite. So opposite over hypotenuse is sine. So we have sine of 61 equals opposite 8.5 over hypotenuse, which I'm going to use as h. So then we multiply both sides by h so that it cancels out on the right. So we have h times sine of 61 equals 8.5, and then we divide by sine of 61, because then it cancels and goes away. So then we have h equals 8.5 divided by sine 61 is 9.718. So then because that's an 8, we round up to 9.72. And then last but not least, for the third side, you can either use the Pythagorean theorem or you can use trig again. Personally, I would probably use trig again simply because then I don't have to worry about any of my rounded values changing my answer, which you will still get points if you have a rounded value but your work matches, then that's fine. But in order for it to have the most accurate, sorry if that was really loud, by the way, to find LM that is adjacent to the 61, so I would actually use tangent so that I can use this opposite measure again. So then tangent of 61 equals opposite 8.5 over adjacent, which I don't know, so I'm just going to label it A so that I can tell the difference. So then we multiply both sides by A, and they cancel out on the right. So then we have A times tangent 61 equals 8.5, and then we divide by tangent of 61. So then A ends up equaling 8.5, oopsie, I can't type on this right now, divided by tangent 61 is 4, let me rewrite that 61, so it actually looks like a 61. Oh my goodness. So then it's 4.711. So then in terms of rounding, gosh, I can't write right now. That would just be 4.71. Okay. So for number 22, we do the exact same thing. So we are given one angle measure, which is really nice because then we can just subtract from 180. So 180 minus 90 minus 22, and that would give us 68 degrees. Oops, degrees. So angle C is 68 degrees. So if I want to find AB, I am going to refer to this angle right here, okay? Because it was given to me, that's just, I mean, you could use a 68 as well, but I like to just use numbers they give me. So if I wanted to find AB, oopsie, that is adjacent over hypotenuse. So that would be cosine of 22 equals our unknown adjacent over our hypotenuse 5.2. So then we multiply both sides by 5.2 so that they cancel out on the right. And then 5.2 times cosine of 22 gives us 4.821. So then that 1 tells us to just keep the 2. So AB is 4.82. And then for AC, that is our opposite side. So we'd have opposite over hypotenuse, which is sine of 22 equals opposite over 5.2. And again, you can use whatever letter you want. I just used the O for opposite. And honestly, I'm going to change my mind because it kind of looks like a 0. So I'm actually going to use an X this time. So again, we're going to multiply both sides by 5.2 so that it cancels on the right. So then 5.2 times the sine of 22 is 1.947. So then that 7 tells you need to round up. So then it's 1.95. Ooh. Woo. Well, I can't write. Okay. I'm just done. Okay. So For number 23, this one's a little bit different because now we have no angle measures. So in order to find it, you're going to have to use inverse trig. So before I do that, I'm going to find side t, which I don't want to select, just want to write. So if you have two known sides, then you can just use Pythagorean theorem. So this one would be 12 squared plus b squared equals 13 squared. And just FYI, in case you did set this up slightly differently, it does have to be this way. The only change you could make is maybe have a squared plus 12 squared instead, but that 13 is the hypotenuse, so that should definitely be by itself. So 12 squared is 144 plus b squared equals 169. When you subtract them, you get b squared is 25, so then b equals 5. So then that means that ST is 5, and actually, fun fact, 5, 12, 13s are just a set of right triangles that you know is worked kind of like a 3, 4, 5. That's also a set of 3 sides for a right triangle that'll work. So then to find angle S and angle R, again, I would probably use the values they give me, even though I didn't have to have a decimal for ST. Still maybe want to use the whole numbers. So if I'm looking at angle S, I have 12, which is opposite, and 13, which is hypotenuse. So then because I'm looking for an angle measure, I'm going to have sine because it's opposite over hypotenuse, but it's going to be inverse sine because I'm looking for an angle. So then 12 over 15 equals S, and inverse sine of 12 over 15 is 53.1. So to round to the nearest degree, it is 53 degrees. Okay, and then to get angle R, you can either subtract from 180, so 180 minus 90 minus 53, which would give you 37 degrees. Or your other option is to use trig again, and if you were to use trig for R, you would probably want cosine, or inverse cosine, I'm sorry, of adjacent, which is now 12, over hypotenuse, which would be 13. And that'll still give you 37 degrees. So, number 24, an electric company installed a vertical utility pole. A utility worker installs a 31-foot wire from the top of the pole to the ground. If the cable makes a 65-degree angle with the ground, find the height of the utility pole and round to the nearest foot. So this is where we draw our pretty pictures. So we have our cute little utility pole. Okay. I'm going to make it nice and thick so I realize it's a pole. And this pole has a wire that from the top of the pole comes straight down to the ground. And if you want, you can even label the picture. It might help some of you. So we know that this wire is 31 feet and it makes a 65-degree angle with the ground. And we want to find this unknown height. So if you want, you could use H or a different letter. It's up to you. But keep in mind, we are rounding to the nearest foot because a lot of people have been messing up where they round. So if I'm doing this, I see the 65-degree angle. The wire is my hypotenuse, and the x is opposite. So the trig function I can use for opposite and hypotenuse is going to be sine. So we have sine of 65 equals opposite x over hypotenuse 31. So then we multiply both sides by 31 to cancel it out. And that would give us, let's save me some writing time, 31 times sine of 65 gives you 28.09. And because we're rounding to the nearest foot, that 0 tells me to just keep it. So it is 28 feet. Okay. All right, so classifying as an angle of depression or elevation, angle 1, remember you're referring to these horizontal lines for both of these. So you have that one and you have this one. So because we're looking at, for angle 1, the perspective of being up in the balloon, we would have to come down or look down in order to see the guy. So angle 1 is an angle of depression because we would have to look down. Angle 2, because we're the guy, we would have to be looking up in order to see the balloon. So it would be an angle of elevation. Okay? So let me do this exact same thing. So angles of depression, looking at this, and I'm actually going to highlight our horizontals. Okay, so looking at this, angle 6 would be an angle of depression. Angle, let's see, how do I want to do this? Okay, so this is, we'll just do all the angles of depression first. So going down is angle 6. Then you also have angle 8 is an angle of depression. So we have 6, 8. And then looking at 10, 11, and 12, those don't have any horizontal lines to base a angle of depression off of, so we're done there. For angles of elevation, remember you're going from the horizontal line up. So that would be angle 7 and angle 9 because you're going from horizontal line up. Now, that leaves, if you haven't been tracking, I'll highlight the ones we've used. We've used 6, we've used 7, we've used 8, and we've used 9. So if you're looking at angles 10, 11, and 12, notice that even though, like angle 12, it technically is touching that horizontal line, it's a 90-degree angle, and it's not really going to be considered an angle of elevation because it's just 90 degrees. It's a right angle. And same with 11. 11 doesn't have a horizontal line that it's getting based off of. It's just this angle, so that's not going to work. And same with 10, there's no horizontal line. So 10, 11, and 12 are all neither. Okay. So number 27, a pilot in a plane spots a forest fire on the ground at an angle of depression of 71 degrees. The plane's altitude is 3,000 feet. What is the horizontal distance from the plane to the fire round to the nearest foot? So the picture may or may not be given to you, so just make sure that you understand how we label this picture. This is the angle of depression. Notice that we had a dotted line for our line of sight so that we had a horizontal line. And then this is our altitude. So because that angle is 71 degrees, I know that this angle in this triangle is also 71 degrees because of alternate interior angles. Okay, we have that Z. So with that being said, if I want to find X, this 3,000 feet is opposite of the 71, and the X is adjacent. So opposite and adjacent is tangent. So we're going to have tangent of 71 equals opposite 3,000 over adjacent. So then we're going to multiply by X. So we have X tangent 71 equals 3,000. And then we'll divide by tangent 71. So then, 3,000 divided by tangent of 71 is 1,032.98. And we are, again, rounding to nearest foot. So because it's nearest foot, that would be 1,033 feet. Okay. So then we have Sarah is standing in a building and looking out of a window at a tree. The tree is 20 feet from Sarah. Sarah's line of sight to the top of the tree creates a 42-degree angle of elevation, and her line of sight to the base of the tree creates a 31-degree angle of depression. Find the height of the tree in feet and round your answer to the nearest foot. So looking at this, again, the picture may or may not be drawn for you. But looking at this, we have two triangles in here, like that, and both of them are right triangles. So when I have to find this, I have to find this segment, and then I also have to find this segment down here. Okay, so we're going to have X and Y. So if I want to find X, we're going to start. X is opposite, and actually so is the Y. And then this 20 feet is adjacent for both of them. So then we're going to have tangent, because it's opposite and adjacent, tangent of 42 equals our unknown opposite over our adjacent of 20. So then we're going to multiply by 20. And 20 times tangent of 42 is 18.008. So it's actually just 18 because, again, nearest foot. So we know that this piece is 18 feet. And then for y, we're going to do the same thing, except now we're looking at 31 degrees. So it's going to be tangent of 31 equals opposite over adjacent. And then we multiply by 20 so that we can get that by itself. And 20 times tangent of 31 is 12.017. So that's about 12 feet. So then finding the height, we have to have this piece and this piece. So we're adding them. So 18 plus 12 is 40. So this is 40 feet tall. Okay. Oops. All right. So a ranger in a lookout tower spots a fire in the distance. The angle of depression to the fire is 4 degrees, and the lookout tower is 32 meters tall. What is the horizontal distance to the fire round to the nearest meter? So we have to draw a sketch. So we have our observation tower, and we see our fire way out in the distance. Okay. Now, our lookout tower is 32 meters tall, and I would say most people can label that no problem. But what people have been having a hard time with is that an angle of depression has to have that horizontal line. So remember, since this is an angle of depression of 4 degrees, your horizontal line, it's actually outside of your triangle like that. So that means that this angle down here is also 4 degrees. So because I want my horizontal distance, that's going to be the bottom side. So then this is opposite and adjacent again. So we're going to have tangent of 4 equals opposite 32 over adjacent x. So then we multiply both sides by x to cancel it out. So then x times the tangent of 4, we have to divide by tangent of 4. So then x equals 32 divided by tangent 4 is 457.6. So that 6 tells us to round up. So then it's 458 meters. Okay. And by the way, you do get points for your pictures, so make sure you draw them. Doesn't have to be perfect works of art. Just make sure you're drawing your triangles and labeling them. Okay. So an observer in a lighthouse is 69 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees, and the angle of depression to the other boat is 22 degrees. Find the distance between the 2 boats and round to the nearest hundredth, and then we're going to draw a sketch. So lighthouse, oops, we have our lighthouse, and then we have our 2 boats. Which is not, there we go. So something to be aware of with angles of depression is that your bigger angle of depression will actually be closer to you. So in this picture, it's actually 48 degrees there and 22 degrees there. So that means that this one, the one closest to the lighthouse, is 48, and this one that's farther away is 22 degrees. And then we said that the lighthouse is 69 feet tall. So because we want to find the distance between them, that is just, let me get a nicer color, this section right here. So remember, there was 2 ways to do this, and depending on your preference, changed how you did it. But most people, I believe, were treating x as the first segment and y as the full length of it. So first you have to find x. So we have our opposite side and our adjacent side, and that'll be for both of them. So we're going to have tangent of 48 equals opposite over adjacent. So then to solve this, we multiply by x and then divide by the tangent of 48. So then 69 divided by tangent of 48 is 62.128. And you don't have to round out crazy far. I usually try and do 2 extra decimal places, so I'm actually going to go out to 79. That way, when we add them or subtract them, it kind of is a little bit nicer to deal with. So then, with the 22, we're going to find the full length. So we have tangent of 22 equals opposite over adjacent. The only thing that'd be different is if you were doing it the other way, you'd probably have y plus this 62.1279. But again, oh no, it's kind of up to you on how, not that. We're going crazy. It's up to you how you want to set it up and solve it. So let me go back to where it was. Oh, there we go. So doing it this way, we're going to multiply by y still, like we did before. So y times tangent of 22 equals 69. And then we divide by tangent of 22. So then y equals 69 divided by tangent 22 is 170.780. Ooh, actually, if you're rounding, 1.7810. So then you subtract the 62.1279. And by the way, make sure you show that too. So 170.7810 minus 62.1279. And again, I know I'm rounding to the nearest hundredth. So that's why I went out 2 decimal places. So this would give you 108.65. And the next digit is a 3. So because that's a 3, it's just 108.65. That's 6, it looks funny. And this is in, let's see, feet. What is this? Feet. Okay. So, oops. With this is our special right triangles, and this is actually the reason why I recorded myself in the first place, because remember, you have your hand trick. So if we are doing sine of 30, remember on the test you are given these diagrams, and you are also given, let me see, do I have space at the bottom? And then you were also, I kind of do, for 30, 60, 90s, and 45s, you were given these little pictures. And I'm going to try and make it easy. So this is a 60, this is a 45. So remember with 45, 90s, your short legs are the same, and your hypotenuse is your short leg times the square root of 2. And then with the 30, 60, 90s, your short leg is x, your long leg is x times the square root of 3, and then your hypotenuse is 2x. And remember, you can use either rule you want. If you're using the method that I just drew with the blue triangles, just make sure you label the triangles if you use that to show your work for it. So for sine of 30, for the sake of practicing with the hand, we are going to do that as well. But if you're stuck with just trying to use the table, sine of 30 is this 30-degree angle is opposite over hypotenuse. So it is 1/2. Or if you're using your hand, which just may be backwards, but sine of 30, 30 is your index finger, so then it's 1/2. Okay, for cosine of 30, if you're using your hand, it is the square root of 123 over 2. Remember, that's always in your hand, so square root 3/2. And then for tangent of 30 is sine over cosine, so square root of 1 over the square root of 3. So that's 1 over square root 3. And then when you rationalize it by multiplying by the square root of 3, you get square root of 3/3 like that. So then for sine of 60, remember that is your ring finger. So sine of 60 is the square root of 3/2, because it's all over 2. And then cosine of 60 is 1/2. Or square root of 1/2, which is just 1/2. And then tangent is sine over cosine, so square root of 3 over the square root of 1, which is just 1. So then it's square root 3/1. 45 is kind of nice because that's your middle finger, and your sine and your cosine are both square root 2/2. And by the way, if you are filling in this table based off of these pictures, you'd have 1 over square root 2, so then you'd have to rationalize to make it the square root 2/2. And then tangent of 45 is just 1/1, which is just 1. Okay, so we have to do these next ones without a calculator, so this is going bye-bye. So to find the value of x, totally depends on which way you do it. So I will do the trig way first. So if I was trying to use trig, I would be referring to this 45 degree. That 8 is opposite, and the x is my hypotenuse. So I would want to do sine, because it's opposite over hypotenuse, of 45 is 8 over x. And then sine of 45, if you're using your hand, you put down your middle finger for 45, is square root 2 over 2. So square root of 2 over 2 is 8 over x. So we'll cross multiply and have x times the square root of 2 equals 2 times 8 is 16. Then we divide by the square root of 2, but we can't leave it like that. So we rationalize by multiplying by the square root of 2 to the top and bottom. So we have 16 square root of 2 over the square root of 4, which many of you already know is 2. And 16 divided by 2 is 8, so then it's 8 square root of 2. Now, this is one of the ones where it would have been way easier just to do the other method. So had you done the other method, you would have needed to label these. And since this is an x, you could also use like a square root of 2. So because a is 8, when we do our hypotenuse, it's 8 times the square root of 2, which is the exact same thing we just got. So if you're using that method, you have to make sure you're putting these labels on here. That way I know, because obviously you can just do it in your head sometimes. That way I know that that is what you used in order to find those values. So for 33, if we were to use trig, I notice that these two angles are congruent, which tells me that they're both 45 degrees. So then this is a hypotenuse. So again, if it helps you, you can have a square root of 2. But if I were to use trig, if I base it off of this 45, I would have opposite and hypotenuse. So I'd have sine of 45 equals opposite 10 square root 2 over hypotenuse, which is x. Sine of 45 is square root 2 over 2. So we have 10 square root 2 over x. So when we cross multiply, we get x square root of 2 equals 20 square root of 2. And then we divide by the square root of 2. So then x equals 20. Now, if I were to use the other method, again, my a is equal to 10 square root of 2. So I take that value and I multiply it by the square root of 2, because that's what they all have to have. So then square root of 2 times the square root of 2 is the square root of 4, which is 2. So 10 times 2 is 20. Notice our answers are the same regardless. So you can use whichever method you want, but again, show me these labels if you are using the other method. So for 34, to find x and y, we have a 30, 60. So if you want to label it, again, this has x, but the nice thing is x is the short leg. So we have x square root of 3, and 2x. Now, I'll show you the shortcut way first, because this one actually works out nicely. So since my hypotenuse is 22, what you can do is just set your rule equal to your value. So 22 equals 2x. So then to solve this, we just divide by 2, and x equals 11. Yay! And then to get the y, well, we already have the rule right here. It's whatever the short side is times the square root of 3. So since my short side is 11, that means it's 11 times square root 3, like that. Now, if you use trig, you could use the sine or the cosine, it'd be totally up to you, of 30 or 60. But if I did, actually, let me change it to purple. If I'd used the 30 degrees and I wanted the x, I would have to use opposite over hypotenuse. So I'd have to use sine of 30 equals x over 22. So then sine of 30, 30 is your index finger. So sine is 1 over 2 equals x over 22. So when you cross multiply, notice these two steps are exactly the same. So then x equals 11, like that. And then if you were to use 30 to find the y as well, you would just use cosine of 30 equals adjacent y over hypotenuse 22. And cosine of 30 is the square root of 3 over 2. So then if you cross multiply, you get 2y equals 22 square root of 3. And then we divide by the 2 to get y equals 11 square root of 3. So again, it does not matter if you use trig or the special right triangle rules. I don't care. But as long, if one way seems easier than the other, you do the other way. It does not make a difference to me. Just make sure you're checking your work and being careful with what you do. All right, so I think we're down, yep, just the last two. So for number 35, if we're using the other way, we have x square root of 3, and 2x. So if you notice with this one, this method may not work as well if you don't want to deal with that x square root of 3. But if we did use it, you would take your rule and set it equal to the value. So x square root of 3 equals 15. So then we would have to divide by the square root of 3. Boop, boop. So then x would be, after we rationalize it, that's where it gets tricky. We have 15 square root 3 over square root of 9, which is 3, and 15 over 3 is 5 square root 3, like that. So you can calculate it like that, and that's fine. Because then once you know that your short leg is 5 square root of 3, if you multiply that by 2, 5 times 2 is 10 square root of 3. So there are ways to make this nice and easy for you. If you did not want to use that method, you could use the 30 or the 60-degree angle, totally up to you. I would probably use the 30 just because it's smaller. I don't know why. But if I use that 30, x is my opposite, and the value they give me is my adjacent. So then opposite and adjacent would give me tangent. So tangent of 30 equals opposite over adjacent, which is 15. And tangent of 30 is sine over cosine. So it's square root 3 over 3 once you rationalize the denominator. Otherwise, it's actually 1 over square root 3 like that. And then when you rationalize, you get square root 3 over 3. So square root of 1 over the square root of 3, and then rationalize. So that would give you equal to x over 15. So we cross multiply and get 3x equals 15 square root of 3. And then we divide by the 3. So then x equals 5 square root of 3. So for some of you, the algebra with the trig functions is way easier than the algebra work by plugging it in. So whichever method you like, you can use either. But then to get the hypotenuse, you would probably want to use cosine of 30 equals adjacent over hypotenuse, which I guess is a y, not an x, y. So then you would multiply both sides by y, and then you would divide by cosine of 30. Oh wait, what am I doing? I got way... Well, I guess technically you could still solve it that way. You guys have done that, but that requires a calculator. So that's why we don't do it that way. I went into autopilot for a second. Haha, just kidding. Did I trick you? Did it work? Did you think I was crazy? All right, so then cosine of 30 is square root 3 over 2. And so then when you cross multiply, you get square root of 3 times y equals 30. And then when you divide by the square root of 3 and rationalize, that's where the rationalizing can make your life slightly easier. You get 30 square root of 3 divided by 3, which then becomes 10 square root of 3, like that. So again, it matches. Sorry for doing that with the calculator method way. So with the last one, this is a 45, 45, 90. Or yeah, 45, 45, 90. So this is x, and x square root of 2. So if you wanted to set or solve it without trig, you would have x square root of 2 equals 16, your rule equal to your value, and then you would have to divide by the square root of 2. So then, because remember, you have to rationalize, this is the pain in the butt part, you have 16 square root of 2 over the square root of 4, which is just 2, and 16 divided by 2 is 8. So then our short leg should be 8 square root of 2. Okay. Now, if you did do it with trig, you could use either of the 45 degree angles, but it would be sine of 45 equals x, opposite, over hypotenuse. Sine of 45 is square root 2 over 2. Okay, so that equals x over 16. And then we cross multiply to 2x equals 16 square root of 2. And then we divide by 2. So again, notice that these two steps eventually look very similar, or these two methods look really similar to each other, and they both end up with the same result. So hopefully this video helped you. If you have any questions, you can comment below. There's also an extra review in Schoology that will be posted sometime today, which today is the 11th. So let me know if you have any questions.